Hi everyone, welcome to week 2. This time we'll be calculating IV flow rates when several solutions are ordered. For the first problem, we can forget about the A, B, and C part. This is all just one big problem. First, let's find how many milliliters we have of our solutions. So here we have 1,000, we have 500, and here we have 500. If we were to add those up, we would have a total of 2,000 milliliters of these solutions. Our instruction says that we are going to use the following solutions for a total of 24 hours. So then we would write this problem as such, so 2,000 milliliters over a period of 24 hours. And then from here we also want to convert the hours as well. You want our answer to be in minutes, since whenever we're looking for drop factors, we need to write it as drips per minute. That's what our final answer should look like. So we should convert these hours into minutes. In 1 hour, there are 60 minutes. So that takes care of the hours part. And as for the milliliters, we have a factor of 15 drips per milliliters. So then we could drop 15 TTT on top, and we can drop 1 milliliter at the bottom, so that can cancel out the milliliters, and we would be left with drips per minute. And once we finish our calculations, we get an answer of 20.83, repeating, but according to our rules of rounding, since this is a larger number than 1, we would technically say it's 20.8 drops per minute. And that should be our final answer. And for this next problem, we can do the same thing. A, B, and C, that's just all one problem. Don't worry about that. So here we have 500 milliliters, 1 liter, and 1 liter. 1 liter is actually 1,000 milliliters. So if we just combine these total, we would have 2,500 milliliters of our solutions. And we need to infuse that in 16 hours. So we would write 2,500 over a total period of 16 hours. Likewise to the previous problem, we need to convert hours into minutes as well, since we are looking for drops. So then in 1 hour, there are 60 minutes, and these would cancel out. And our drop factor is, in 1 milliliter, there are 10 drips. So then milliliters would cancel, and now we're left with drops per minute. And once we do our calculations, we find that we have 26 drops per minute. This next problem is different. It says that our order is 900 milligrams, but we're going to infuse that in 75 milliliters. So there are two separate numbers, and we're not going to really mess around with 75 yet. So what we're going to do is we're going to convert the 900 milligrams into milliliters, because that's what our measurement indicates it to be. So we're going to get the 900 and convert that to milliliters. And there are 150 milligrams in 1 milliliter. And then the milligrams cancel out, and we are left with 6 milliliters at the end. So now we're going to go back to the 75 milliliters, and since the problem originally says that we're going to have the 900 be placed in the 75 milliliters, we can just combine these two numbers for a total now of 81 milliliters. So now we're going to calculate the rate based off of the amount of solution that we have. So we have our 81 milliliters. in the beginning of the problem, it said that we need our solution, which would be our 81 milliliters, to be placed in 30 minutes. So we're going to write this as 30 minutes. And in our drop factor is 10 drops in 1 milliliter. Since our problem states that that's what our drop factor is, so then once we do this, the milliliters will cancel out and we're left with drops per minute. And once we do the math, we have 27 drops per minute total. This next problem is a little bit different. So according to the instructions, we have a solution that needs to be administered at a rate of 2 MEQ per hour. So then part A says that we should get that rate and convert it to milliliters per hour. So that's what we are going to do now. We have our 2 MEQ per hour, as the original problem stated. And we are going to convert this to milliliters per hour. So then we're going to be doing that according to the first part of the problem, which states that there is 20 MEQ that will be placed in 1 liter. That is our conversion factor. So 1 liter is actually 1,000 milliliters. So now using this, we can now find milliliters per hour. So we will be using this conversion factor. Say that there are 1,000 milliliters in this 20 MEQ solution. So then those can cancel out and we'll be left with milliliters per hour. So then once we calculate this, we would get 100 milliliters per hour. And that is our final answer. And now the second part of this problem wants us to take our previous answer and change that to accordance of 15 drops per milliliter. Wants us to find the rate for that. So we're going to take our previous answer so then we convert the hours to minutes. So in 1 hour there are 60 minutes. And in 1 milliliter there are 15 drops. So now hours can cancel, milliliters can cancel, and our final answer would be consisting of drops per minute. And our final answer will be 25 drops per minute. In this next problem, 100 units of this insulin is added to the 500 milliliters of this solution. So we would write this as 500 milliliters with the 100 units in the 500 milliliters. And it says that we need to find our answer in milliliters per hour. And here we're also given the fact that there are 10 units per hour. So that is our conversion factor. So then, since we have units on the bottom, we can put units up here. There are 10 units per hour. So then units cancel, and we are indeed left with milliliters per hour. So then our final answer would be 50 milliliters per hour. In this next problem, an IV is regulated at 20 microdrops per minute. how many hours will it take for 100 milliliters to infuse? So basically the problem's asking us to find our answer in hours for a total of this 100 milliliters to infuse. So we take the 100 milliliters that we have, and we're going to use the conversion factor of microdrops, since that's what the problem states. So in 1 milliliter, there is 60 drops. And according to our conversion factor, there are 20 drops in 1 minute, and there are 60 minutes in 1 hour. So this is going to give us our final answer in hours, because milliliters cancel, drops cancel, and minutes cancel. So our final answer comes out being a total of 5 hours. This next problem says an IV is regulated at 17 microdrops per minute. So that means it's going to be in unit of macro. So the drop factor is given, and the question asks how much fluid volume in milliliters will the client receive in 8 hours. So we need to find the volume in milliliters. So we're looking for the amount of fluid in a total of 8 hours. So in 8 hours, we need to find how much was given out. So from here, we're going to convert those 8 hours and find those milliliters from it. So in 1 hour, there's 60 minutes. And as the problem states, our conversion factor would be 1 minute has 17 drops. And since we are in macro drops, that means that there are 15 drops per minute. Per milliliter. So that means hours cancel out, minutes cancel out, and the drops cancel out, giving us a final answer in milliliters. So once we plug in all our numbers, we would get a total of 544 milliliters. This next problem, we start off with 180 milliliters of our solution, and here we have our conversion factor. The drop factor is 15 drops, okay? So how many hours will the fluid last? So we would start off with 180 milliliters. According to the problem, 1 milliliter consists of 15 drops. And then there are 45 microdrops in 1 minute. So the milliliters cancel out, drops cancel, and our answer would be, after doing all calculations, 60 minutes. In this next problem, we have a solution that is being infused at a rate of 45 microdrops per minute. The drop factor is 15 drops per milliliter. And the question asks how many milliliters would the client receive in a total of 8 hours. So this is similar to one of the previous problems that we did. So we're finding the amount of the solution that was given out in 8 hours. So in a total of 8 hours, we're going to find how many milliliters we've administered. So we're going to convert this. In 1 hour, there's 60 minutes. And according to our conversion factor, in 1 minute, there's 45 drops given out. And our conversion factor is 15 drops per milliliter. So then hours cancel out, minutes cancel out, and so do drops. So our final answer is 544 milliliters. This next problem is different. We have 1,000 milliliters that was supposed to be given at this rate, but but we can ignore that part because the next part says that we have 700 milliliters after 4 hours. Our drip factor is 15 drops per milliliter. We're supposed to recalculate the flow for the 700 milliliters left. So that means we're going to start off with the 700 milliliters that we have left over the time span of 4 hours. So this is what we're working with. And we have to calculate the rate that is left over. So we're going to convert hours into minutes. So 1 hour is 60 minutes. And our conversion factor is that 1 milliliter is 15 drops. So then our final answer roughly comes up about being around 40 drops per minute. In this next problem, it says that an IV consisting of 1,000 milliliters was supposed to be distributed a total of 8 hours. So our drop factor is 10 drops per milliliters and our rate is 20. So 5 hours have gone past and 700 milliliters were used up. So out of a total of 1,000 milliliters that we had, 700 were already used. So that gives us a total of 300 milliliters that we have left. And out of a total amount of 8 hours that we had, 5 hours already have gone by. So we have 3 hours left. This is an exceedingly fast rate. So what we should do now is we should reduce the rate. And by that, we're going to calculate what our new reduced rate will be. So this becomes our ratio. And we're going to convert this into drops per minute. That is our new rate. We can ignore this old rate because that was our previous one. We're recalculating our new rate. So we are going to convert hours to minutes. So we have in 1 hour we have 16 minutes. And according to our drop factor, in 1 milliliter, there are 10 drops. So hours can cancel, milliliters can cancel, and we have drops per minute. So after we do our calculations, we have roughly about 17 drops per minute. So our next problem is similar. We originally started off with 250 milliliters of this solution, and we had infused it in total 3 hours at a certain rate. But we have 1.5 hours remaining. So our drip factor is 15 drops per minute, and we have 200 milliliters left. So we need to recalculate our rate. So we have 200 milliliters, a total of 1.5 hours. We're going to use our drop factor. So in 1 milliliter, we have 15 drops because we're supposed to look for drops per minute. And we're going to convert those hours. And in 1 hour, we have 60 minutes. So then milliliters cancel, hours cancel. We're left with drops per minute. And once we do our calculations, we get a total of 13 drops per minute. For this problem, we have a solution of 1,000 milliliters that was supposed to infuse in 12 hours and at this certain rate. But 4 hours have gone by and 250 milliliters have gone. So out of a total of 12 hours that we have remaining 8 hours. And out of the 1,000 milliliters that we had, 250 milliliters were already used. So we have 750 milliliters left over that we are going to work with. So now we're just going to recalculate our rate. So we have 750 milliliters, the remaining 8 hours. And then our conversion factor is 20 drops in every milliliter. So then hours cancel, milliliters cancel, and we're left with drops per minute. And after we do our calculations, we have roughly 31 drops per minute. Hopefully you found this video helpful, and best of luck on your homework.